Hi guys, Ms. Rosacker here. We are going to start our statistics unit. So we're going to start with some definitions, and then I'm going to show you guys how to use your calculator and how we're going to analyze some data. This is really important because it is very real world based, and it also is a really big part of the SAT. So you guys are going to make sure that you're following along, that you know how to do these in your calculator, especially the calculator tricks, because they're going to help you massively on the SAT. Okay, so we're going to start with just like basic vocab. So when you ask what is statistics, it is basically just a numerical fact or calculation formed from a quantity of data. So you just get a bunch of data and then it's a fact that you come up with that's based on numerical or calculations. And then there are two different types of data that we work with. There's single variable data and there's two variable data. Single variable data is looking at one set of data. So specifically like how far away do you live from school? Or like how tall is everybody? So it's just like one statistic, one variable that you're looking at. And we represent this with bar graphs, dot plots, histograms, box plots, and so many more different ways. The two we're going to focus on for this class are going to be box plots and histograms. And then you also have two variable data sets, which is comparing the two sets of data. So you have like age versus text messages sent, or like year in school versus amount of homework and things like that, where you have two different sets of data and you're comparing them. And then those are represented with scatter plots. So you put one set of data on the x-axis, one set of data on the y-axis, and then you compare them. So they make like XY coordinate points. Okay, and then there's two different types of data. You have numerical data and you have categorical data. So numerical data is quantitative data, is numerical information such as like temperature or weight or hours, something that has a number based on it. Whereas categorical data is qualitative, which is descriptive information. So like eye color, it describes something. The color of the wolves that are in Antarctica or something like that. So it's really like descriptors versus numbers. Okay, so when we get into data, there are ways of describing and analyzing data, and there's four elements that you need to consider when analyzing the data. There's four things we got to look at. There's the center of the data, the spread of the data, the shape of the data, and the outliers, if there are any. So we're going to start with center. The center is, it says, a measure of central tendency is a single value that attempts to describe a set of data by identifying the central position or the center within that data. And there's three different ways that we can measure the center. And depending on our data and depending on how it's laid out and if we have outliers and different things, we use a different central tendency to tell us about our set of data. So one of them is the mean, and that's the average of the numbers. So you guys know you just add up all of your data and you divide by the total. That's how you get your mean. And the problem with this one is this is susceptible to outliers. So if I have outliers, we don't want to use the mean. And then the median is the middle number. So if I put all of the numbers in sequential order from the lowest all the way to the highest, and then I find the middle, that's going to be your median. And then the mode is the one that appears the most. So this is rarely used to describe center because just because it's the most doesn't necessarily mean that it's at the center of your data. Okay, so these are two things you guys definitely want to write down because we're going to use this a lot. So it says when to use the mean to describe the center. You want to use the median when there are outliers in the data set, meaning the data is skewed and is not symmetric. So if there are outliers, you're using the median. So are outliers, you're going to use the median. And then when to use the mean is when the set of the data does not contain outliers. That means your data is symmetric or skewed. So mean is when there are no outliers. So you have to know the difference between those. And then we don't use mode really. Mode just tells you the most, which isn't necessarily the middle. Okay, another thing we talk about is the spread of the data. So kind of how far spread out are they from the middle of your center of your data. So one thing that you guys probably know is your range is your maximum value minus your minimum value. That's not really used a whole lot to do spread. Sometimes they like to look at it, but it doesn't give us a really good range of how far things are from the middle of our data. One that we do use is the interquartile range or the IQR. And we'll get into this when we talk about box plots here in a little bit, but really this is just your quartile 3 minus your quartile 1. And then this is important to note that these are used when there are outliers. So if there are outliers, you're going to use the interquartile range to find your spread of data. And then you have a standard deviation, which is just a number used to tell how measurements for a group that are spread out from the average or the mean, how far are they from the average. A low standard deviation number means that the numbers are close to the average, and a high standard deviation means that the numbers are more spread out. This is not a good measure when there are outliers. So if you have outliers, you do not want to use standard deviation. And then on the calculator, we'll talk about this, but it's the S of X whenever we go to that data. Okay, the next thing we can do is we can talk about the shape of the data. So when describing a histogram, you have to use two different descriptions. You have to first decide if it's one of the following, if it's uniform, if it's single peaked, or if it's double peaked. And then next you have to decide if the graph is symmetric, skewed left, or skewed right. And then when you're doing a box plot, these are the only descriptions you need. So you're definitely gonna wanna write these down. The first thing is if it's uniform, meaning all of the bars in your histogram are the similar height, so all of your things are the same height. Single peaked is the graph has a single area where the data is the highest. Double peak has two areas where the data is the highest. And then symmetric means one side of the graph looks like the other. Skewed means the data falls more heavily on the left or the right, not in the center. So these are kind of backwards. So if it is called skewed left or left skewed, if the peak is on the right side, it looks like your left foot. So if you're looking at your head, your left foot is down on the bottom, most of your body is up on your right side. And then skewed right, the peak is on the left. So over to the left, you're looking at your right foot, all of your body weight is towards your left side when you're looking at your right foot. And these are the only descriptions you need when doing box plots. Okay, so these are histograms. They're basically bar graphs, but they're all connected together and there's not really any gaps. So what we're gonna do is we're gonna describe these things. So when I look at this first one, the first description you have to decide is if it's uniform, single peaked, or double peaked. So when looking at this one, it looks like it is all really about the same height. So I'm gonna say this is uniform. And then the next description you have to think about is if it's symmetric, skewed left, or skewed right. And so to me, all of these bars look like they are matching on the same side. So it's not really having one side taller than the other. So I think that I would say that this is symmetric. So uniform, symmetric. Then when we look at this one, we're gonna start with, is it uniform, single peak, or double peak? This one is definitely double peak because there are two places where the graph is higher. So this is double peaked. And then to me, this looks like it is symmetric because both sides have kind of the same height of the bar. It's not leaning one direction or the other direction. So this is a double peaked symmetric. Okay, this one is gonna be a single peak. Oops. And symmetric, because it's matching on both sides. So this is kind of like your normal bell curve, if you guys know what that is. And then this one is definitely going to be a single peak, but this one is skewed. So now let's go back up to our skewing. So you can see that most of your data is on the right side up here. So if I go back up here, the peak is on the right side, means that it is skewed left, meaning all of this data is being pulled to the left side. So this is a single peak, and it is also skewed left. Okay, and then when we talk about box and whisker plots or box plots, that's what these things are. You have the same idea. So if you have a whisker that is longer on your left side, that means this is left skewed. So most of your data is on the right side. Hurry. And then this one, your whiskers are matching. So this is symmetric. And then on this one, your whisker is more on the right side. Most of your data is on the left side. So this is a right skewed shape. So that's how we talk about shape, and that's what you guys are going to use. In histogram, you need to make sure you use two things. And in the box plots, you only need to say one. Okay, so then we have outliers, which I think a lot of you guys know. Outliers are the values that lie outside of the other values. So if we look at this first example, you have all of these data values that are really close to each other, and then you have this one that's really far away out here. This is your outlier. The outliers cause the mean or the average of the data to be skewed or pulled to one side or the other and not represent the true average of the data. So here's an example that we're gonna go through. So it says long jumpers extra distance they have added to their jumps by practice this month. So we're looking at this one, and you have a bunch of people that have added just a little bit of positive meters to their jumps and their long jumps. And then you have Sam over here who has lost 0.56 meters, which is way out here. So this is an outlier because he's really far away from the rest of the data. And if I find the average of this, where I'm finding the mean and including him in here, it's making the mean be pulled down more towards this outlier versus being in the middle of most of the data. So if I were to remove Sam and look at the mean again, then the mean is more right in the middle of all of our data. So whenever you have an outlier, it pulls the mean or the average towards that outlier, whether it's lower or higher. So in this case, it's lower, so it's pulling your mean down, so it's making everybody look like they're not improving their jumps on average, even though the majority of people are. Okay, so what we're gonna do is we're now gonna use our calculators, and we're gonna learn how to plug in and create box plots and histograms, and then also just look at these one variable steps. So go ahead and get your calculator out. And what we're gonna do is we're gonna start by looking at the single variable data we're going to use is this. So I'm gonna walk you guys through how we do this. So in your calculator, the first thing you're gonna do is you're gonna click the stat button, then you're gonna click enter, and then you most likely have data in here that isn't matching. So for me, it does match, but if you have data that doesn't, you're gonna arrow up to where this is bold, you're gonna click clear, enter, and then it clears out your whole list. And then you're just gonna go ahead and type in this list. So you do 2, 7, 9, 12, 14, 22, 32, 36, 43. And then there's this check sum. So we're going to talk about that in a minute, but this is a way to check if you actually plugged in all of your numbers correct. So the first thing we're going to talk about is how to just get to your single variable data. So what it says is you're going to now, once you have all of your data entered, you're going to click stat, you're going to arrow over to calc, and then where it says 1 bar stats, you're going to click enter, and then go down to calculate. And then you get a list that looks like this. And so this is what the explanation of all of these are. But the first thing you want to check is this check sum. So it says this is the sum of the data when you have this little sum with the X. So this is 177. When you first enter things in, you want to make sure that this number matches the check sum. And that means that you put all of your numbers in correctly. Then what these other things mean is this X bar, yeah, it's called an X bar because it has a bar over it, is the mean or the average. So this is your mean. This guy is the sum of the squares of the data, which we don't really use. This is your standard deviation. So when we're talking about spread, this is what you use. This is also standard deviation. So this one is for a sample population and this one is for a population. And we're not going to get too deep into that right now. The one you're going to use for my class is this SX. The N is the number of data points that you put in into your calculator. And then you have this 5-number summary that's down here, which is going to help us make our box and whisker plot. So this one is your minimum. This one is your quartile 1. This is your median, quartile 3, and then your maximum. So this is considered our 5-number summary that we're going to use to create our box and whisker plot. So what we're going to do is you have making a box and whisker plot. First, you need to plug all of that data in just like we just did, and then you're going to identify your 5-number summary. So we have our 5-number summary here, and then we're just going to write it off to the side. So it tells us that our minimum was 2, our quartile 1 was 8, our median was 14, our quartile 3 was 34, and then our maximum was 43. So this is considered your 5-number summary. And then that's what builds your box and whisker plot. So you have median is right in the middle. Quartile 1 is the middle of your lower half. Quartile 3 is the middle of your upper half. And then you have your maximum and your minimum. And then what you do to create your box and whisker plot is you use these numbers. So the minimum comes down here. And the minimum is usually like a dot. So their minimum would be 2. Then your quartile 1, you put a line. Median, you put another line wherever that's at. Quartile 3, you put another line. And then maximum, you put a dot. And then you create this box. So that's how you make your box and whisker plot, is truly with your 5-number summary. And then in order to make this in your calculator, what you do is you have all your data entered in there. So you would do stat, edit, make sure all your data's in there. And then you are going to go second y equals, and you need to turn one of these stat plots on. So my number 1 is on. I'm going to go down to number 2 here and turn this one off. And then I go back here. So enter. You want to make sure that this is on. And then I'm going to go do a box and whisker plot. So it's already highlighted for me, but if it's not for you, you're going to arrow over here and you're going to highlight this box and whisker plot and click enter. And then when you go to graph, you're going to see this, and you may not see it. Do zoom number 9, so it zooms it into your stats, and then there's your guys' box and whisker plot that matches just like this. So that's how you guys can make one on your calculator. And then we just want to talk about the center, the spread, the shape, and the outliers. Okay, so it says In this one, the center, so either it is going to be the mean or the median. And in this case, let's start with outliers. Do we have any outliers in this set of data? Is there a number that stands out? Not really. I mean, 43 is a little big, but it does have things that are close to it. And this box and whisker plot look pretty symmetric. So I would say that there are no outliers. So if there are no outliers, then that means that we are going to use the mean to calculate our center since there are no outliers. So then you just go to that 5 number or back to your one variable stats right here. And then your mean is this X bar. So our center of our data is about 19.67. And then we want to know the spread. So again, we're saying there's no outliers. So if there's no outliers, then the spread is going to be using the standard deviation. And so we're looking at this SX for our standard deviation. So it's spread out by 14.34, meaning most of my data points are about 14.34 away from the mean. And then we want to use the shape. So this is a box and whisker plot. So we only need to say if it's skewed left, skewed right, or symmetric. So for me, this one looks like it is symmetric. Okay. Last thing we're going to do, and then I will do a different video walking you guys through kind of how to do this as a combination box and whisker plot, is what a histogram is. So in looking at this histogram, again, this is just basically box or bar graph where they're all connected. So there's 2 words you have to know when you're working with histograms. The first word is a bin width. The bin width is how wide you want your bars to be. So this is the width of your bars. And then the number on the far right side is always going to be less than that for the bar that it's next to. So since this is 15, all of the numbers in this bar are between 0 all the way up to like 14.999, but it's not 15. So this is always going to be less than your right number on your bin width. And then frequency, this is represented by your y-axis. And this is just the number of elements from the data in that bin or bar. Okay, and it gets analyzed the exact same way as a box plot. So all of those things, the center, the spread, the shape, and if it has outliers, are analyzed the exact same way. Okay, so we're gonna use the same data you guys have in your calculator to make a histogram. So we're gonna go back to our calculator. You shouldn't have to enter new data. If you do, you just go stat, edit, enter, and type it in here, but you should already have this. And then what we're gonna do is we're gonna go up to our stat plot and we're gonna change this from being a box and whisker plot to being a histogram. So I'm gonna go and I'm gonna turn this histogram on. And then if I click graph, I can see that it's creating a histogram for me. Now there's a couple of things that we have to do in order to see this entire thing. We have to change the bin widths and we also have to change the X scale. So you're gonna go to window. And then what we want to do is we want to change the X max and min right here. So this is our lowest and highest. So this looks like our lowest number was 2. So I'm going to change this to be 0. And then our highest number is 43. So we have to make it something that's at least 43. So how about 45? So that this encompasses all of our data, highest to lowest. And then this X scale is what we want our bin widths to be. So this X scale is what we're going to change it to be. So let's change that to be 10 for this one. And you can kind of play around if you want. And then you're gonna go to graph, and then you can see a little bit better of a histogram. And then if you want an even nicer one, you can do zoom number 9, and it'll zoom right in on those stats. So then what's nice about this is you can click trace, and you can move around, and it'll tell you what each of these bin widths are and how many elements are in there. So if we look at this first one, this tells me that this goes from 0 all the way to 12.25. Let's see, that changed on me. Let's see, 54, and then let's make this be 10. And then let's go, or not 54, what did we want that to be? 45. Go back to graph, there we go. Okay, so then we do trace, and then, see, I want that to be 0. There we go. Okay, so now we do trace, and then it's going to tell me that the minimum here is 0, and it goes all the way up to 10. So if I was going to create a graph over here, this is going to be our frequency, and these are going to be our bins. So the first one we have is between 0 and 10. And then what this tells me, this N tells me that there are 3 elements in this bar. So I'm going to go up a height of 3, and I'm going to create my bar here. That means 3 elements in this list are less than 10. And then I can arrow over, and then it tells me my next bin width goes from 10 to 20, and that there's 2 elements in there. And then I can arrow over again, and then this one goes up to 30, and there's only 1. And then 40, and then there's 2 in this one. And then I can go back, and then we end at 50 over here, and I only have 1. And so then that's gonna be your guys' histogram, all right? And then we do interpret it the same way. So let's just go through and write those same things down. So if we're describing the graph, let's first start with outlier. The same data, it doesn't look like there's any outliers. It looks like it's all pretty close together. So there's no outliers. So for center, if there's no outliers, that means we use the mean, and our mean should match the exact same data that we had above. But remember, if you forgot, you just go back to stat, over to calc, and then one variable stats. And then the mean is this very first one. So your mean for this is going to be 19.67 like it was above. The spread, since there are no outliers, we're using the standard deviation again. So your standard deviation for this one was 14.34, which again, if you go back to this list, standard deviation is just this guy. Shape, now to this one, it doesn't look like I would say this is pretty uniform. Maybe you could say double peak. It looks a little double peak. Let's say double peak. And then I would say symmetric. There's no huge difference between the left side and the right side. They're pretty symmetric, and it's not leaning towards one direction or the other. Okay, so what you guys are gonna have to do is I'm gonna give you some data. You're gonna have to be able to plug in your calculator and create graphs that look like this, and then you're gonna have to be able to describe your data, whether it has outliers or not, and how you go about describing the center, the spread, the shape, and the outliers. Okay, so I'm gonna create another video here in a second that shows you how to do a combination, box plot and histogram, so that you can see both of them on your calculator, and then you guys can use that to kind of analyze your data. So it is important to just know how to plug these in, and then it's also really important that you guys have all of this vocab up here written down so that you kind of know how to analyze, and the big ones are, again, just center, spread, shape, and outliers. Okay, so look out for video number 2, and then you guys are gonna do some practice.